In a world run by physics, the idea that awareness is something that isn't just found in living things might seem strange. Still, new studies in astronomy, neuroscience, and quantum physics show that this idea is scientifically plausible. Some new discoveries, like integrated information theory's measurement of consciousness as a function of information integration and quantum entanglement's strange non-local connectivity, suggest that reality itself may have a basic level of awareness built in. We are being asked to think about the possibility that what we normally think of as lifeless cosmic matter could, in some situations, act like a huge global brain. This point of view not only questions the usual separations between mind and matter, but it also opens the door for a conversation between different fields that combines real science with philosophy, questions that have been around for a long time. Historical development of cosmic consciousness ideas. Ancient civilizations saw the universe not as a collection of motionless things, but as a living, breathing entity, long before modern science came along. Mountains, rivers, and trees were all seen as homes to gods or aware beings in ancient mythology, which gave rise to a belief that the natural world was alive and full of soul. The earth is frequently portrayed as a caring and self-aware mother figure in many cultures, including indigenous American traditions, ancient Greek mythology, and shamanistic activities across Asia. A notion of the cosmos as an interdependent sentient being was born out of these early ideas. In ancient Greece, thinkers like Thales and Anaxagoras advanced early notions that suggest a cosmic consciousness. Thales, often regarded as the first philosopher, posited that everything is full of gods, implying that natural elements have a divine spark. Anaxagoras introduced the concept of nous, mind or intellect, arguing that a cosmic mind was responsible for the organization of the universe. Plato later elaborated on these ideas by proposing the concept of the anima mundi, or world soul, in which all living and non-living things participate. This notion of a universal spirit influenced subsequent philosophical traditions and provided an early framework for thinking about the cosmos as a sentient whole. The idea of a living universe continued to evolve through the Middle Ages. Medieval mystics and theologians, while deeply rooted in the religious doctrines of their time, also embraced the notion of a cosmos that was more than mere inert matter. Although the dominant view in medieval Europe was shaped by Aristotelian physics, which distinguished between the animate and inanimate, there persisted a belief in a divine, unifying presence. This was evident in the writings of mystics who spoke of experiencing an all-encompassing divine presence within nature. With the Renaissance came a renewed interest in reinterpreting the natural world, blending empirical observation with speculative thought. Visionaries like Giordano Bruno challenged the prevailing geocentric worldview by suggesting that the universe was infinite and imbued with life. Bruno's radical ideas, though controversial, invited his contemporaries to consider that the cosmos could be a living, conscious entity, echoing the ancient myths, but now in a context that hinted at a scientific understanding of nature. From mythical ideas to philosophical beliefs and early science theories, these important events in history show that people have always been interested in how the universe works. As empirical methods and scientific study got better over the years, the argument slowly changed. Symbolic myths were the first way that people started to understand what they were reading. Observation and reason then led to debates about awareness and its place in the universe. Even though our ancestors didn't have a lot of scientific knowledge, they were interested in the idea that the universe might not only be alive, but also have some kind of consciousness. This is an idea that modern science is now starting to look at again with new empirical insights. Early philosophical perspectives on a living universe. Rather than seeing the universe as a fixed set of parts, ancient Greek philosophers saw it as a sentient, intelligent, and ever-changing whole. Anaxagoras, who first proposed the concept of nous, mind or intellect, as a basic principle, was one of the first to contribute to this theory. Nous, the intellectual energy that moved matter and created order from chaos, was the driving force behind the universe, according to Anaxagoras. The cosmos, he said, was sentient in and of itself, and it was this cosmic mind that was to blame for the universe's perfect order. Plato further developed these early ideas by proposing the concept of the anima mundi, or world soul. In dialogues such as the Timaeus, Plato posited that the entire cosmos is a living creature endowed with a soul that pervades every aspect of reality. According to Plato, the universe is not merely an aggregation of lifeless objects. Instead, it is a single, unified organism in which every part is interrelated and participates in a greater, rational whole. This vision of a living universe implies that natural phenomena, from the rotation of the planets to the growth of plants, are expressions of a universal, divine order. Plato's idea of the world soul laid an essential foundation for later philosophical and mystical explorations, suggesting that the separation between the living and the inanimate might be an artificial construct of human perception. These early Greek perspectives did more than simply assign life and intelligence to the cosmos. They also challenged thinkers to reconceptualize the nature of existence itself. By attributing a form of consciousness to the universe, philosophers like Anaxagoras and Plato blurred the boundaries between mind and matter, opening the door for subsequent inquiries into the relationship between the two. Their insights prompted later generations to consider whether the processes of thought and life might be inherent properties of the cosmos, rather than qualities confined solely to human beings or other living organisms. The emphasis on nous and the world soul had a profound influence on the development of metaphysical and religious thought in both the Western and Eastern traditions. In the West, these ideas were integrated into the later works of Neoplatonists such as Plotinus, who refined the notion of a single transcendent source from which all reality emanates. This blending of philosophy with spiritual inquiry set the stage for medieval mysticism, which continued to explore the idea that the cosmos is imbued with a divine, unifying presence. Eastern traditions and the concept of oneness in the cosmos. Eastern philosophical traditions have long believed that the world is not a collection of separate things, but rather a single linked mind that permeates everything. In Hinduism, for instance, Advaita Vedanta is one of the most important ways to understand how everything in the universe is connected. Advaita, which means non-dual, says that Brahman is the ultimate truth and that it is one, endless, and the source of everything. For this point of view, the human self, Atman, is not different from Brahman, it is one with it. There are no longer any visible boundaries between the watcher and the observed. This radical oneness suggests that every particle of matter, every breath and every thought is a representation of a single, all-encompassing mind. Similarly, Buddhism presents its own nuanced take on cosmic oneness. Zen Buddhism, in particular, emphasizes direct experiential insight into the nature of reality. Through practices such as meditation and mindfulness, Zen teaches that the self is an illusion, a construct of the mind, and that true understanding comes from recognizing the interdependent nature of all phenomena. This realization, often described as satori, or sudden enlightenment, reveals that the division between subject and object is illusory. By seeing through this duality, one comes to appreciate that every being, every element of nature, and the entire cosmos are interconnected parts of a unified whole. Taoism also contributes a profound perspective on cosmic oneness through the concept of the Tao. The Tao, often translated as the Way, is understood as the fundamental principle that underlies and unites the natural world. It is an indescribable force or process that is both the source and the pattern of all existence. Taoist thought posits that the universe flows in a natural, harmonious rhythm and that everything in nature is in constant transformation, yet part of the same dynamic process. This view encourages adherents to live in accordance with the Tao, embracing simplicity and balance as ways to align oneself with the cosmic order. Across these traditions, there is a common thread: the recognition that the distinctions we perceive between self and other, mind and matter, are ultimately superficial. Instead of viewing the universe as a mechanistic assembly of disparate parts, Eastern philosophies propose that reality is fundamentally holistic. This holistic vision implies that consciousness is not a byproduct of complex biological structures, but rather an inherent feature of the cosmos itself. Advaita Vedanta, Zen, and Taoism all have ideas that have affected spiritual practices, and also given modern scientists and thinkers a lot of words to use when they are trying to figure out what awareness is. On the other hand, some modern philosophical readings of Panpsychism agree with the idea that each person's awareness is a localized expression of a global mind. In addition, these Eastern points of view go against the main Western paradigm, which tends to divide information into rigid, limited groups. Eastern religions show the world as a living, organic thing where matter and mind are deeply linked by stressing how everything is tied to everything else. Western thought, from mysticism to modern cosmology. Western ideas have a long history of seeing the universe as more than just a bunch of inert things. These ideas have changed over time, starting with spiritual beliefs and ending with scientific research. In the Middle Ages, religious and philosophical views of the world put a lot of emphasis on the spiritual presence and the inner life of everything. This led to a rise in mysticism. Mystics in the Middle Ages often said that nature was like a mirror reflecting God's love and knowledge, with a spark of the holy in every part of creation. At the time, these explanations were strongly rooted in religious beliefs. However, they also hinted at the possibility of a world with life and purpose beyond just mechanical processes. The Renaissance brought about a dramatic reawakening of curiosity regarding the natural world, spurred by the rediscovery of classical texts and the advent of empirical observation. Visionaries like Giordano Bruno challenged the prevailing geocentric view and the notion of a finite, static cosmos. Bruno boldly argued that the universe was infinite and animated by a living, unifying force. He proposed that every part of the cosmos, from the stars to the tiniest particles, was interconnected through a vibrant cosmic spirit. His ideas, radical for his time, were met with fierce opposition from religious authorities, yet they planted the seeds for a more expansive view of the universe, one where the boundaries between the living and the inanimate began to blur. In the 17th and 18th centuries, scientific methods got better. This made early modern thinkers start to see how actual study and the idea of a living, changing universe could go together. René Descartes, for example, created a two-part understanding that separated the mind, res cogitans, from the rest of the world, res extensa. Some people afterwards said that his strict separation of mind and matter was wrong, but his work led to more research into what awareness is and how it relates to the physical world. Baruch Spinoza, on the other hand, presented a strong option with his monistic theory. Spinoza thought that mind and matter were not two different things, but rather two parts of a single, unifying reality. This idea was summed up in his phrase, Deus sive natura, God or nature. This radical idea of a universe that is alive and linked set the intellectual groundwork for later theories that say awareness is a part of the universe itself. By the time of the Enlightenment, the shift toward rationalism and empiricism had transformed how scholars viewed the universe. The mechanistic view of nature, championed by figures such as Isaac Newton, provided powerful mathematical descriptions of physical phenomena. Yet even as Newtonian physics dominated scientific thought, there remained an undercurrent of wonder regarding the nature of life and consciousness. This tension between a mechanistic understanding and the intuitive sense of a vibrant living universe spurred ongoing debates. Some thinkers argued that a purely materialistic account was insufficient to capture the fullness of experience, suggesting instead that the universe might possess a subtle, pervasive form of consciousness. With the rise of astronomy and astrophysics in modern times, people are once again interested in these old questions. Modern cosmology theories, like the Big Bang and the cosmic web, show that the universe is incredibly complicated and linked, which is similar to ideas that were more spiritual in the past. Now scientists are looking into how the huge network of galaxies and the complex patterns of matter might be similar to the brain's neural networks. This is leading to new ideas about how the universe is connected. The conversation between empirical science and philosophical research has changed how we think about the cosmos. We no longer see it as a lifeless space of matter, but as a living, changing thing where awareness, life, and the physical world are all connected. Neural networks and the cosmic web, structural parallels. The structural similarities between the neural networks in the brain and the cosmic web that shapes our universe are one of the most interesting ways that neuroscience and astronomy meet. At first look, the brain, which is made up of billions of neurons and is very tightly connected, might seem very different from galaxies and dark matter, which are made up of very long filaments that stretch across billions of light years. But new discoveries in complexity science and network theory show that these two systems share basic rules for how they are put together that control how they connect, handle information, and organize themselves. In the brain, neurons communicate via synapses in intricate networks that are responsible for everything from basic sensory processing to higher-order cognition and self-awareness. These networks exhibit a high degree of modularity, where clusters of neurons form specialized circuits for distinct functions. At the same time, they maintain an overarching integration that allows disparate regions to interact and exchange information, a balance that is crucial for coherent thought and behavior. Scientists have mapped these networks using tools such as functional magnetic resonance imaging, fMRI, and diffusion tensor imaging, DTI, revealing a rich tapestry of connections that mirror the principles of small world and scale-free networks. Such networks are characterized by short path lengths between nodes and a few highly connected hubs that act as central communication centers. In the same way, the cosmic web, which is the big structure of the universe, is made up of a web of galaxies, galaxy groups, and strands that are mostly made up of dark matter. This structure is not spread out randomly. Instead, it has a well-organized design that was created by gravity forces acting on it over billions of years. The cosmic web is made up of nodes, which are groups of galaxies that are linked by long strands and have huge gaps in between them. Using astronomical studies like the Sloan Digital Sky Survey, SDSS, researchers have found that the universe has both modularity and integration features, which are similar to how neural networks work in the brain. In the cosmic web, dense points act as gravitational hubs, pulling matter in and linking with many strands. This is similar to how certain parts of the brain act as communication hubs for neurons. Network theory provides a framework for understanding these similarities. Both the brain and the cosmic web operate on principles of self-organization and emergence. In the brain, local interactions among neurons give rise to complex global patterns of activity that underpin cognitive functions. Similarly, in the cosmic web, the gravitational interactions among galaxies and dark matter particles lead to the emergence of large-scale structures without any central planner. This bottom-up emergence from simple rules to complex behavior is a hallmark of complex systems, whether in biological or cosmological contexts. Studies in complexity science have shown that both neural and cosmic networks are remarkably efficient at information transmission and processing. In the brain, the small world architecture ensures that information can travel rapidly between different regions, facilitating real-time responses to external stimuli. In the cosmic web, the distribution of matter minimizes the distances over which gravitational interactions must occur, optimizing the transfer of energy and matter across vast distances. This efficiency in connectivity is not only an aesthetic or mathematical curiosity, it may also hint at a deeper underlying principle that governs all complex systems, regardless of scale. One more thing that these networks have in common is that they can be changed. When new things happen, neuroplasticity says that the brain can change how it works, We can heal from accidents, learn new things, and see our brains change over the course of our lives because of this. A lot like how the cosmos web is not a set scheme, but one that changes over time. It gets bigger as galaxies merge, new stars are born, and cosmic strands move and change shape. Even though the time frames are very different, both systems are strong and adaptable, constantly changing how they work in response to forces inside and outside the system. Empirical evidence of cosmic connectivity. Modern science has gathered a lot of real-world proof that the universe is not a bunch of separate, unrelated things, but rather a web of connections between all of them. Astronomy, particle physics, and even systems biology have made interesting observations that point to the possibility that the world might be connected in a way that is similar to how living systems are linked. Astronomical surveys, such as those conducted by the Sloan Digital Sky Survey, SDSS, have revealed that galaxies are not randomly scattered throughout space. Instead, they form a vast cosmic web, a filamentary network of galaxy clusters and superclusters interwoven with enormous voids. This large-scale structure demonstrates that matter in the universe organizes itself into patterns that are remarkably similar to the networks seen in biological systems. The gravitational pull among galaxies, dark matter, and dark energy drives the evolution of these structures, suggesting an underlying coherence in the way matter is distributed on a cosmic scale. At the microscopic level, the phenomena of quantum mechanics provide additional evidence for cosmic connectivity. Quantum entanglement, for instance, shows that particles can become linked such that the state of one instantaneously influences the state of another, regardless of the distance between them. Experiments, such as those confirming Bell's inequalities, have repeatedly demonstrated that this non-local connection is not merely a theoretical construct, but a real, measurable phenomenon. Although the full implications of quantum entanglement for macroscopic systems remain a subject of ongoing research, these findings challenge the classical notion of isolated particles and hint at a deep-seated, universal interconnectedness. It is also supported by research in systems biology and complexity science that things at all sizes are linked. Cells in biological systems talk to each other using biochemical messages and networks that keep balance and coordinate function. Ecosystems are also made up of complex webs of relationships between living things and the places they live. Not only are these ways of talking and responding important for the survival of individual species, but they are also necessary for group behavior to develop, like flying and swarming, and even for human social dynamics. The similarities between these biological networks and the cosmic web seen in astronomy suggest that there may be general rules for how things link. Aside from these observations, theory models are also starting to connect the real world with the abstract. For instance, scientists who have used network theory to look at both brain and cosmic systems have discovered that they share traits such as modularity and the appearance of hubs with a lot of connections. These models suggest that the speed with which information moves through the brain is similar to how gravitational waves move around galaxy groups. This means that basic rules of connectivity may be at the basis of both awareness and the structure of the universe. Emerging interdisciplinary approaches are exploring how these empirical findings might be synthesized into a unified framework. Some scientists and philosophers argue that if the universe's large-scale structure and the non-local properties of quantum mechanics both point to an inherent connectivity, then the possibility of a cosmic-level information processing system becomes more plausible. While these ideas are still in the realm of hypothesis and require further experimental verification, they provide a promising avenue for rethinking the relationship between the physical and the experiential. The cosmic brain hypothesis, foundations and controversies. With the cosmic brain hypothesis, the world as a whole works like a big brain with a huge network of connections that can handle and combine information. This idea comes from strong similarities between the way neural networks are organized in the brain and how the universe is organized on a big scale. The vast network of galaxies, clusters, and dark matter in the cosmic web might work like a huge, spread-out information processing system, similar to how billions of brains work together to make things like thought and awareness possible. Supporters of the cosmic brain theory say that this comparison is backed up by a number of basic facts. To begin, it's interesting to note that both the brain and the world are very flexible. In the brain, groups of neurons in the same area work together to make specialized circuits that do specific tasks. Central hubs bring together information from different parts of the brain. Astronomical studies show that the universe is structured into packed nodes called galaxy clusters. These nodes are linked by filamentary structures, creating a huge network that moves matter and energy across the cosmos. The fact that these structures are similar suggests that the basic ideas behind self-organization and efficient connections may be the same at both the tiny and macro-scale levels. Those who support both methods also say that they make it easy to share knowledge. The small world network design in the brain makes sure that messages move quickly through the neural landscape, which helps the brain respond quickly to information. The gravitational pull of galaxy clusters and dark matter strands create paths in the cosmic web that make it easier for energy and information to move over very long distances. Some scientists even think that these structures in space might do more than just move energy around. They might also process information in a way that is similar to how synapses send messages. If this is true, the world might be seen as doing some kind of computational or cognitive work. This idea has huge effects on how we think about intelligence and awareness on a global level. Some people don't agree with the cosmic brain idea, though. One major point of contention is the question of emergence versus internal design. Some people say that the similarities in structure between the brain and the universe might not be proof of a global mind, but rather the result of convergent evolution in complex systems. People are interested in whether the very specific chemical processes that run a human brain can really be matched with the universe, which is run by gravity and dark matter. From this point of view, the similarity between neural networks and the patterns of the universe may be more poetic than scientifically sound. The question of causation and usefulness generates still another major debate. Neurons in a human brain interact via well-known electrochemical processes, producing subjective feelings and observable behaviors. Galaxies and dark matter interact essentially differently, driven by gravity rather than synaptic signals. Critics wonder, does the cosmic web truly compute in a way that would produce something like awareness, even if its structure reflects that of a neural network? Furthermore, the theory has to contend with the combination problem, that of how basic, maybe proto-conscious parts, from a panpsychist perspective, might mix to create a unified global awareness akin to a brain. The cosmic brain idea also makes me think about how we know what we know. What effects on the world could we see if it really is handling information on a cosmic scale? Some supporters say that things like quantum entanglement and non-local connections might be signs of this basic information processing going on in the universe. But critics say that these ways of looking at things risk mixing up metaphor and process, and that the evidence we have now is too patchy to back claims of a truly cognitive world. Panpsychism, consciousness as a fundamental property. A philosophical perspective known as Panpsychism holds that consciousness is a universal inherent aspect of the cosmos. Panpsychism contends that even the most basic elements of the cosmos have some type of fundamental experience. Not that consciousness is an emergent quality that occurs just in highly sophisticated biological systems. From dualism, which strongly separates the mental from the physical, and from conventional materialism, which usually considers mind as subordinate to matter, this point of view presents a significant break. Panpsychism maintains that awareness is a basic characteristic, similar to mass or charge, rather than the result of intricate arrangements of matter. Proponents contend that reductionist techniques fail to address the hard problem of consciousness, the task of explaining how subjective experience comes from physical processes. In contrast, if consciousness is a fundamental quality of matter, the evolution of sophisticated, self-aware brains in animals such as humans becomes less mysterious. David Chalmers, a prominent figure in current philosophy of mind, has identified panpsychism as a potential alternative since it provides for a naturalistic account of experience without the involvement of mysterious non-physical objects. Panpsychism's ability to avoid the so-called hard problem is one of its strongest points. Panpsychism says that even the smallest particles might have proto-conscious qualities. This way of thinking doesn't ask how consciousness suddenly shows up at a certain level of complexity. These simple events don't come close to the rich subjective life of a person, but they are the building blocks that can lead to more complex conscious states if they are put together in networks that are complex enough. It's possible for awareness to exist at the smallest levels of matter and in all of human experience. This point of view is sometimes called micropsychism. Recent advances in fields such as quantum physics and complexity science have also provided a renewed impetus for panpsychist ideas. For instance, the phenomenon of quantum entanglement, where particles become correlated in ways that defy classical explanations, hints at a deeper level of interconnectedness that could be interpreted as a form of shared proto-conscious experience. Moreover, the mathematical formulations of integrated information theory, IIT, imply that even systems not traditionally considered alive might possess a non-zero degree of consciousness based on the amount of integrated information they process. Panpsychism does have some problems, even with these good points. One of the main complaints is the combination problem, which asks how simple, separate conscious experiences can come together to make the complex, combined awareness that higher animals have. Some people say it's still not clear how the experiences of basic particles, which seem to be very different, can come together to make human awareness, which is a rich, uniform stream of consciousness. A lot of people have thought about how to solve this problem. One idea is the idea of proto-phenomenal traits that connect in a non-linear way. Panpsychism still has a lot of problems though, like this one. There are worries about how well panpsychism can be tested. Because the theory says consciousness is fundamentally different from normal sense experiences, it can be hard to come up with tests that prove beyond a doubt that elementary particles have proto-conscious states. But supporters say that the lack of direct proof doesn't necessarily mean that the theory is wrong. Instead, they say that it shows how limited current methods are and how we need new scientific techniques to study consciousness at its most basic levels. Philosophers such as Philip Goff have argued vigorously in favor of panpsychism, emphasizing that it provides a parsimonious solution to the explanatory gap between physical processes and subjective experience. Goff contends that if we accept that consciousness is a fundamental aspect of the universe, then many puzzles in the philosophy of mind and cognitive science begin to make sense. Similarly, other contemporary thinkers like Galen Strawson have embraced variations of panpsychism, arguing that the experiential aspect of the universe is something that must be accounted for in any complete theory of reality. Basic mechanisms of neuronal communication and their cosmic analogues. The amazing powers of the human brain are mostly derived from a complex system of communication that depends on quick signal transmission between neurons. Basic functioning units of the brain, neurons interact via specialized connections known as synapses. An electrical impulse, often known as an action potential, passes along a neuron and reaches the synapse to release chemical messengers called neurotransmitters. These neurotransmitters pass the synaptic gap and attach to receptors on a nearby cell, therefore delivering the signal and allowing the coordination of several cognitive processes. From sensory experience to abstract reasoning, this process, marked by its speed, accuracy, and adaptability, forms the basis for everything. Interestingly, some of these communication processes find intriguing analogues on a cosmic scale. In the vast expanses of the universe, matter is organized into an enormous network known as the cosmic web, a structure composed of galaxies, galaxy clusters, and interconnecting filaments predominantly made of dark matter. Just as neurons communicate across synapses, the elements within the cosmic web interact through gravitational forces and energy flows. Gravitational interactions act as the messengers in the cosmos, drawing matter together into clusters and filaments and orchestrating the large-scale structure of the universe. These gravitational forces are not static, they are dynamic, continuously shaping and reshaping the cosmic architecture, much like the synaptic transmissions in the brain facilitate the dynamic processing of information. Energy runs through cosmic structures in a way that is similar to how chemicals move through the brain. In an accretion disk around a black hole, for instance, matter swirls inward, giving off energy as radiation as it gets hot. This exchange of energy is like how chemical energy is produced during synaptic communication. In both cases, there is a change. Electrical impulses in the brain are changed into chemical messages that carry important information. Gravitational energy is changed into electromagnetic radiation that shines on the processes going on. These energy swaps are necessary for both systems to stay stable and grow. They make sure that information is sent quickly, whether it's in the form of cosmic energy or neural signals. The idea of feedback loops reveals again another amazing resemblance. Feedback systems in the brain assist control neuronal activity, therefore enabling activities including homeostasis, memory consolidation, and learning. Analogous big-scale operation of feedback systems is found in the cosmic web. For example, by heating the surrounding gas, the radiation released by accreting matter in galaxies can affect star formation rates and thereby control galaxy development. Both environments depend on this self-regulating behavior. In the cosmos, it guarantees that the expansion of structures continues in a balanced, coherent way. In neural networks, it preserves the balance between excitation and inhibition. Both methods are also very adaptable. The brain can change how it works, which is called neuroplasticity. This helps the brain adapt to new situations, heal from damage, and eventually work at its best. Cosmic structures are always changing because of gravitational pulls and energy transfers. For example, galaxies merge, new stars form, and cosmic gas clouds fall apart and spread out. They're not set in stone. The way brain networks are constantly changing shows how flexible they are and stresses that new qualities, like awareness, can come from complex, adaptable systems. Integrated Information Theory, IIT, and Cosmic Information Processing. First put out by neuroscientist Giulio Tononi in 2004, Integrated Information Theory, IIT, presents a mathematical framework for comprehending consciousness by suggesting that the capacity of a system to integrate information directly determines its degree of awareness. IIT is fundamentally based on the numerical measure phi, which measures the degree of interlinkability among the components of a system and the whole system's more than the sum of its parts. IIT claims that whilst systems with lesser degrees of integration may have limited or no consciousness at all, a system displaying a high degree of integrated information is able to generate rich, unified conscious experiences. IIT challenges traditional views by suggesting that consciousness is not an emergent property that appears only at certain levels of biological complexity. Instead, it argues that consciousness is a fundamental property that can be quantified in any system that integrates information. For example, while a simple light switch might have a negligible phi, the highly interconnected networks of the human brain achieve a much larger phi, corresponding to the vibrant subjective experience we associate with consciousness. This approach has provided a novel perspective for neuroscientists and philosophers alike, as it shifts the focus from neural activity alone to the architecture of connections that underlie cognitive functions. The ideas behind IIT are interesting, because they can be used for things that happen in the world as well as live things. This brings us to the idea of handling information in space. To handle information, the brain's neurons work together in intricate networks that are always changing. It's possible that the cosmic web of galaxies, dark matter strands, and galaxy groups also works like a very large computer system. If the universe connects and combines information in ways similar to neural networks, then it's possible that it does so in a way that could lead to a form of awareness, though on a much bigger scale, and in a way that is very different from how our brains do it. In this speculative but increasingly discussed framework, cosmic information processing would involve the integration of information across the vast networks that make up the cosmic web. The gravitational interactions among galaxies and dark matter create a structure where information about the distribution of mass, energy, and motion is continuously transmitted and processed over astronomical distances. While the mechanisms are fundamentally different, governed by gravitational dynamics rather than electrochemical signals, the underlying principle of integration remains the same. If integrated information is indeed the substrate of consciousness, then the universe might harbor a very low-level, diffuse form of consciousness distributed throughout its structure. Scientists who believe in universal information integration say that quantum entanglement and non-locality could be proofs of the idea. If two particles are related, they will always show similarities, even if they are very far apart. In other words, data about one particle is sent right away to its buddy. Theoretically, this built-in link at the quantum level could help make a kind of data that is sent all over the world. These ideas are still just guesses and haven't been proven, but they make for an interesting connection between the small-scale processes that IIT talks about and the world's large-scale moves. Neuronal networks, ecosystems, and the cosmic web are just a few examples of the numerous complex systems studied by researchers. These systems have commonalities in aspects including modularity, feedback loops, and emergent behavior. These similarities make it seem like the same physical and mathematical rules might control how knowledge is combined on very different levels. So even though IIT was first created to explain awareness in humans, its main ideas might work for any network that is complicated enough, even the ones in the universe. Of course, extending IIT to cosmic scales is not without significant challenges. One major issue is the measurement of integrated information in systems that are not closed or well-defined, like the human brain. The cosmic web, for instance, is a continuously evolving structure influenced by numerous external factors, making it difficult to compute a coherent value for phi. Additionally, even if one could measure integrated information at the cosmic level, it remains an open question whether a high phi in such a system would correspond to any form of consciousness comparable to what we experience. Extending IIT to the universe, possibilities and limitations. The main goal of integrated information theory, IIT, was to find a way to measure awareness in biological systems, especially the brain. Its main idea is that the number, phi, shows how much information a system can integrate. This amount of awareness is then determined by the system. Researchers have started to wonder if IIT's ideas can be applied to non-biological or even cosmic scales. IIT has given us a lot of interesting information about how awareness is linked to the brain. We will talk about the pros and cons of using IIT to understand the whole world in this part. Perhaps one of the most intriguing ways to expand IIT is to think that the cosmic web, which is made up of galaxies, dark matter, and strands that connect them, could also be described by a certain amount of integrated information. The huge structures of the world are related in ways that are organized, efficient, and always changing. This is similar to how neural networks in the brain are very integrated because of how closely they are linked. If we could think of gravity events as the sending and receiving of information, then parts of the universe with a lot of matter, like galaxy groups or filaments, might have a value that is not zero. The idea that the universe may have a general low-level consciousness, a kind of cosmic awareness that comes from putting together knowledge from astronomical distances, is a fictional but appealing one. The extension of IIT to the cosmic scale is fraught with conceptual and practical challenges. One major difficulty lies in defining the boundaries of the system under investigation. In the human brain, the boundaries are relatively clear, a closed, complex organ with well-defined neuronal interactions. In contrast, the cosmic web is a vast, open, and continuously evolving network with no clear edges or isolated subsystems. The universe is subject to constant influxes of energy, matter, and radiation from various processes, making it difficult to compute a coherent value for integrated information. Without a well-defined system, measuring phi becomes a formidable task. The way things engage in the cosmic web is another problem. Synaptic transmission, which uses electrochemical signs that have been studied a lot, is a clear way to measure how information is integrated in brain systems. The universe's relationships, on the other hand, are mostly controlled by gravity and dark energy, which work on very different scales and in very different ways than living systems. Even though gravitational forces are good at arranging matter into galaxies and groups, they don't have a set way of processing information like synapses do. So, even if we agree that the cosmic web is connected in some way, it's still not clear if these relationships can be explained in terms of integrated information in a way that makes sense, which is what IIT needs. If a technique were developed to determine a cosmic phi, the interpretation of such a measurement raises more problems. In IIT, a rich, unified conscious experience is connected with a high phi. In the context of the cosmos, though, what would a high or low phi mean? Would a high cosmic phi mean that the universe undergoes a sort of awareness similar to human consciousness? Or would it be a totally new kind of experience, unrelated to the human mind? With quantitative approaches, the qualitative elements of consciousness, subjectivity, qualia, and the unity of experience are rather difficult to describe. One of the main constraints in pushing the theory beyond of the biological domain is this difference between the quantitative rigor of IIT and the qualitative richness of subjective experience. There's also the issue of whether or not it can be tested in the real world. Neuroscientific techniques like fMRI and EEG make it possible to connect what is recorded with what people say they experienced. On the other hand, if you tried to measure integrated information on a cosmic scale, you might have to use secondary methods like looking at the structure of the universe, how gravity works, and how energy is distributed, which might not directly relate to the idea of awareness. If you don't make clear statements that can be tested, expanding IIT to the universe might just stay a philosophical exercise instead of a solid science theory. Quantum entanglement and non-local connectivity in the cosmos. The entanglement of quantum particles is one of the most puzzling and well-studied ideas in modern physics. Particles in entangled systems become connected so that the state of one quickly matches the state of another, even if they are far apart. This non-local connectivity goes against what we usually think about, cause and effect, and how separate things are. It suggests that at the most basic level, the world might work in a very linked way. Experiments that confirmed Bell's inequalities showed that entangled particles have strong relationships that don't fit with any local hidden variable theories. These findings suggest that an entangled particle can instantly get information about the state of a particle that is entangled with it. Albert Einstein famously called this spooky action at a distance. While entanglement has mostly been used in quantum computing and safe messaging, it has far-reaching effects on how we understand the universe that go far beyond the lab. The idea that quantum entanglement might underlie a form of cosmic connectivity has sparked intriguing speculation among some physicists and philosophers. If entanglement is not just a feature of isolated quantum systems, but rather a pervasive property of the universe, then it could serve as a mechanism by which different regions of the cosmos remain interconnected. This non-local bonding might help explain how seemingly isolated cosmic structures can exhibit coordinated behavior over vast distances. For example, the correlations observed in the cosmic microwave background radiation, relic light from the early universe, could be influenced by primordial entanglement, imprinting a subtle, universal order onto the fabric of space-time. People who believe in an aware world also say that these kinds of quantum events might have effects on the nature of consciousness itself. They say that if entanglement makes it possible for particles to join instantly, then maybe similar processes could make it possible for a kind of shared collective awareness. This way of thinking fits with some versions of Panpsychism, which say that even the smallest particles have traits of being aware. In this way of thinking, the universe's entangled state could be seen as a huge connected web of information, a base for a broad cosmic awareness. But there are still big problems that need to be solved before we can fully understand the connection between quantum entanglement and the birth of awareness. Even though entanglement is a well-known physical effect, its role in making the world more connected on a big scale is still hotly debated and being studied. Most of the time, quantum effects happen on a tiny level. It's not yet clear how or if these effects can be properly applied to larger structures, like galaxies or the cosmic web. Some people say that decoherence, which is the process by which quantum systems lose their entangled qualities when they interact with their surroundings, might stop entanglement from playing a big part in big cosmic processes. The observer effect, consciousness and quantum measurement. The observer effect is one of the most puzzling parts of quantum physics. It means that the act of observing quantum systems seems to change how they behave. Particles like electrons behave differently when they are being watched versus when they are not, as shown in the famous double-slit experiment. When no one is looking, electrons can behave like waves, making interference patterns that show they move through both holes at the same time. As soon as it is known which slit an electron goes through, however, the interference pattern goes away, and the particle acts like it only went through one slit. What part does the viewer play in deciding what reality is? This big change makes us think deeply. The observer effect suggests that the properties of quantum systems are not fully defined until measured. Some interpretations of quantum mechanics, notably the Copenhagen interpretation, attribute this indeterminacy to a collapse of the wave function, the mathematical description of a quantum system, which resolves into a definite state upon observation. From this perspective, the very act of measurement is not a passive receipt of information, but an active process that brings certain properties into being. Some theorists have speculated that this phenomena might be closely related with quantum measurement, and that consciousness itself might be also. Proponents contend that consciousness might be a basic feature of the physical universe if the observer effect is more than a quirk of measuring instruments. That is, if the observer's conscious awareness causes the wave function to collapse. Under such a perspective, the mind actively shapes reality by choosing among quantum possibilities rather than only an emergent feature of brain activities. Many worlds theory says that all possible events happen in branching parallel realities, so there is no need for an aware spectator. Many people, though, think that the idea that awareness picks one branch over others is a more logical explanation. This is especially true when you think about how each person experiences a unique, continuous world. From this point of view, it's possible that consciousness and quantum physics are closely connected, with observation and maybe even awareness itself being an important part of how physical things happen. Some people say that giving consciousness a special place in quantum measurement could mix up philosophical thought with real-world science. They say that the spectator effect can be fully explained by how measuring tools and quantum systems interact with each other, without bringing up awareness itself. Still, the argument is still going on because scientists are still doing tests to find out the limits of measurement and what quantum reality is. In the context of cosmic consciousness, the observer effect takes on additional significance. If consciousness is indeed fundamental, as some interpretations of quantum mechanics suggest, then the interplay between observer and observed might not be confined to isolated laboratory experiments, but could be a universal principle. The holographic principle and the nature of cosmic information. The holographic principle is a novel idea in theoretical physics. It says that all the information in a volume of space can be shown as recorded data on the space's lower dimensional edge. The principle questions the way we usually think about how information is spread in the world. It came about when scientists studied black holes and quantum gravity. Instead of seeing space as a three-dimensional box where data is stored in terms of volume, the holographic principle says that cosmic data is really stored on a flat surface, similar to how a hologram can turn a flat recording into a three-dimensional image. This idea originated from the work of Gerard T. Hooft and Leonard Susskind, who sought to resolve paradoxes related to black hole thermodynamics. They noticed that the entropy of a black hole, which measures the amount of information it contains, scales with the area of its event horizon rather than its volume. This observation led to the bold hypothesis that, at a fundamental level, the universe might operate similarly. The vast amount of information defining the structure and behavior of our cosmos could be encoded on a cosmic horizon. In this view, the three-dimensional world we experience would be a projection of data that is stored on a distant, lower dimensional boundary. There are many applications of the hologram concept that go far beyond black holes. If the universe as a whole follows the same rules, then space-time could be seen as an information-rich patchwork, with each part of the universe linked by the way they store and send data. This point of view is interestingly similar to ideas in quantum gravity, which says that space-time and gravity come from quantum bits being entangled with each other. As academics dig deeper into these links, they find signs that what we think of as the smooth flow of space-time may actually be a reflection of more basic informational processes. The holographic principle's promise to offer a fresh perspective on cosmic awareness is among its most intriguing features. If all physical processes could be characterized in terms of information, then consciousness, often defined as a process of information integration, might likewise be seen through this prism. Under this perspective, the cosmos may be seen as a massive information processing system where the development of the universe computes, depending critically on the boundaries encoding the cosmic data. This idea combines apparently different disciplines. Quantum physics, cosmology, and information theory come together to imply that the universe could have an inbuilt capacity to process information, maybe resulting in a type of diffuse universal awareness. The hologram structure changes the way we think about reality in a big way. Physical events might not be limited to a three-dimensional space, but could be qualities that appear from a deeper, more abstract database. In this picture, the line between mind and matter gets less clear because both are seen as examples of basic informational processes. With its complex networks and neural connections, the brain handles huge amounts of information in a way that may not be too different from how the universe stores and codes information on its edge. This point of view supports the idea that consciousness might not be a result of complicated brain circuitry, but rather something that is built into the universe. This fits with some readings of Panpsychism and dual aspect theories. Even so, study into the holographic principle is still going on, and it's still not clear how it can help us understand cosmic awareness. Some people disagree with the idea, saying that while it is technically beautiful and gives us a deeper knowledge of black holes, using it to think about the beginning of consciousness may go beyond what we can prove with facts right now. It's hard to make the connection between the subjective, hard-to-measure parts of consciousness like qualia, meaning, and self-awareness, and the mathematical concepts of holography. Black holes as information hubs in the cosmic brain. It was one of the most surprising findings in black hole physics to find out that a black hole's entropy, which is a measure of how chaotic or full of information it is not related to its volume but to the area of its event horizon. The idea behind what is now called the Bekenstein-Hawking entropy formula was first put forward by Jacob Bekenstein. Stephen Hawking later built on it through his work on black hole radiation. The formula suggests that all the information about matter that has dropped into a black hole is not lost in the hole's seemingly empty center, but is instead stored in some way on its flat surface. The holographic principle is based on the idea that all of a region's three-dimensional information can be shown on its two-dimensional surface. This finding went against what most people would think. If we extend this notion to a cosmic scale, black holes could be viewed as critical nodes in the vast network of the universe's information system. In the cosmic brain model, these nodes serve as repositories or memory centers, where information about the state of the universe is concentrated. The idea is that just as neurons in the brain collect and transmit signals to create a coherent stream of consciousness, black holes might aggregate and process information, contributing to the integrated dynamic network of the cosmos. Their role as information hubs may be essential for understanding the large-scale structure of the universe and the emergent properties of cosmic consciousness. The process of Hawking radiation suggests that black holes are not completely isolated from the rest of the universe. Instead, they slowly evaporate over time, emitting radiation that carries away bits of the information previously contained within them. This radiation, while seemingly random, may actually hold clues about the internal microstates of the black hole. In a sense, Hawking radiation could be analogous to the neural firings that signal changes in the brain's state, offering a glimpse into the thought processes of the cosmic network. If black holes truly serve as information hubs, then their radiative emissions might be viewed as part of a larger feedback loop that influences the evolution of the universe. Finding a solution to the famous black hole information paradox is another interesting thing about black holes. This paradox asks how information can stay intact when matter goes into a black hole. There are many ideas, some based on the hologram principle and quantum gravity, that say information is never really lost, but is kept in a jumbled state on the event horizon. This idea that information stays the same fits with the idea that the world, like a brain, keeps a record of its past states by sending and receiving information through complicated networks. In this situation, black holes are not just harmful forces, they are necessary for keeping the universe's information in order. Some people who are against the cosmic brain model say that we still don't fully understand how black holes process information, and that it is still very hard to connect these processes to the start of awareness. The rules that govern black holes' physics are very different from those that govern the electrical reactions in neural networks. Still, the basic similarities, like how information is stored on borders and how information is constantly being sent and received through radiation, make it interesting to rethink the role of these very different things. Energy flow and information transmission in accretion disks. Accretion disks, which are huge moving clouds of gas and dust that circle around very heavy celestial objects like black holes or young stars, are very important places in the universe for changing energy. Matter swirls inward because of gravity. As it does this, it gets very hot and sends out energy across the electromagnetic spectrum. This process is not only a stunning example of gravity physics, but it's also an interesting example of how energy flow can be used to send information on a cosmic scale. In an accretion disk, the motion of particles is governed by a combination of gravitational attraction, friction, and magnetic forces. As these particles interact, collisions and viscous effects cause them to lose angular momentum. This loss enables the matter to gradually spiral inward toward the central mass. The gravitational energy released during this inward movement is converted into thermal energy, leading to extreme temperatures that can result in the emission of X-rays and other high-energy radiation. The pattern and intensity of this radiation encode information about the physical conditions within the disk, such as its density, temperature, and composition. This process of change is a bit like how information is sent in neural networks in some ways. Synapses make neurotransmitters, which are chemical messages that let cells talk to each other. Neurons send electrical signals. The flow of energy and the light it makes in an accretion disk also show important details about the state of the system. Different ideas or sense cues can be shown by changes in the way neurons fire. For the same reason, changes in the accretion disk's range and brightness can reveal what is happening physically below. Observations from space telescopes like the XMM Newton from the European Space Agency and the Chandra X-ray Observatory from NASA have helped us learn a lot more about accretion rings. Astrophysicists can now map the temperature distribution, velocity fields, and chemical makeup of accretion disks in a lot more detail thanks to these devices' high-resolution pictures and spectra. For example, researchers can figure out how well the disk around a black hole turns gravity energy into radiation by looking at the X-rays it gives off. This process depends on the shape and motion of the disk. Magnetic turbulence can drive the transport of angular momentum, leading to more efficient inward flow of matter. This magnetic activity not only influences the disk's overall stability, but also plays a role in launching powerful jets of particles perpendicular to the disk plane. These relativistic jets, observed in many active galactic nuclei, serve as channels for transmitting energy and potentially information across vast cosmic distances. The feedback from these jets may even regulate star formation in surrounding regions, further linking the microphysics of accretion to the broader evolution of galaxies. The role of relativistic jets in cosmic communication. These narrow beams of high-energy particles are thrown out at almost the speed of light from areas around supermassive black holes in the centers of busy galaxies. They can also come from neutron stars and young stars. Their research not only showed the strange physics at work near black holes, but it also raised the idea that these jets might be ways for space aliens to talk to each other, sending energy and data over very long distances. Relativistic jets are produced when matter accreting onto a black hole is funneled along the magnetic field lines that thread the accretion disk. The intense gravitational forces near the black hole twist and amplify these magnetic fields, creating conditions where particles can be accelerated to relativistic speeds. Once ejected, these jets pierce through the surrounding interstellar medium, sometimes extending for hundreds of thousands of light years. The jet's ability to travel such immense distances without dissipating their energy entirely is remarkable, suggesting they could play a significant role in shaping their galactic environments. From the point of view of communication, these jets could be used to send energy and, in a figurative sense, information. The structures inside jets are not all the same. Along their length, they show changes in color, direction, and makeup. You can think of these differences as messages or signs about the physical processes going on at the jet's source. For instance, changes in the brightness of the jet could store information about the black hole's changing growth rate or its changing magnetic field structure. In this way, the jets could be seen as cosmic data streams that send information about how things are moving in the center of busy galaxies. It's even more clear what role relativistic jets might play in a unified, talking universe because of how they interact with their surroundings. As jets move through space, they can squeeze gas clouds and start the birth of new stars. This has a big effect on how galaxies evolve. One effect of this feedback is that it changes the structure of galaxies. It may also help create a link between the powerful actions of black holes and the overall movement of the universe. The idea of using relativistic jets as ways for spaceships to talk to each other goes against how we usually think about sending information. Synaptic links between neurons in the brain speed up the transmission of information. The ways they work are very different, but the idea behind them is very similar. Moving, directional flows of energy can store and send information. If we take this comparison further, jets could be thought of as the axons of the universe, sending important messages across vast distances. This new way of looking at things adds an interesting layer to what we know about the universe. It makes us think that the universe might be a complex, interconnected system where energy flows are not just random releases, but planned, purposeful processes. There are, however, still some problems that need to be fixed before relativistic jets can be proven to be real information carriers. Because jet physics is so complicated and happens on such large scales, existing data and theory models can only give us a small glimpse of how it works. We know a lot more now thanks to high-resolution images and spectral analysis, but we still need to make more progress in observational technology and theoretical theories to fully understand the language of these jets, if there is one. Fine-tuning of physical constants and the emergence of consciousness. The world we live in is very well tuned in ways that are hard to explain by chance alone. Scientists have found that for life to exist, many of the basic constants that describe how the world works need to be set to very specific numbers. Some of these constants are the force of gravity, the force that holds atoms together, and the speed at which the world is expanding. Any change to these ideals, no matter how small, would make life impossible. Stars and planets would not form, and there would be no complicated science to make cells that can live. People who are aware would not be able to wonder about the world without those circumstances. The cosmological constant, which keeps the universe expanding at a certain speed, is one of the most extreme cases of fine-tuning. Space would grow too quickly for galaxies to form if this constant were just a little stronger. If gravity wasn't so strong, it would push everything back together before stars and planets could form. Some experts say that this constant's range is so small that it's like hitting a target that's only a few atoms wide from anywhere in the universe that can be seen. Fine-tuning might not be a random mistake after all, some people think, because it is so precise. It might be part of something deeper and more important. The connection between fine-tuning and the emergence of consciousness starts with the fact that life cannot exist without complex structures. Complex structures like stars, planets, and biological cells only form because the physical constants allow it. For example, inside stars, carbon atoms are formed through a process that depends on extremely specific nuclear energy levels. Without this special process, carbon would be rare, and life as we know it would be impossible. This makes fine-tuning essential for the building blocks of life, and without life, there would be no thinking beings to observe the universe. This makes consciousness directly linked to fine-tuning in ways scientists are only beginning to understand. Some scientists use the anthropic principle to explain this connection. The anthropic principle is the idea that we see the universe as fine-tuned because if it were not, we would not exist to see it. In other words, the constants of nature had to fall within the right range for conscious beings like us to appear. While this sounds like common sense, it raises deeper questions. Does the universe have to create conscious beings? Is there a built-in rule that makes sure the universe evolves in a way that allows consciousness to emerge? Some scientists believe this is possible, meaning that consciousness is not just a lucky accident, but something the universe was always heading toward. More than that, some people think that the laws of physics might change over time. The universe's rules might not have been set in stone from the start. Over time, they could change to allow for more complexity. Being complex is important because life and thought would not be possible without it. Stars, planets, live cells, and one day brains are all very complicated processes. If the world naturally tends to get more complicated, then fine-tuning might be a way for it to organize itself. This would mean that fine-tuning is not a set of rules that don't change over time, but something that the world is doing to make awareness more likely. Some thinkers go even further and ask whether consciousness itself plays a role in shaping the universe. This idea comes partly from quantum physics, where experiments show that the act of observing something can affect how it behaves. This is known as the observer effect. Some scientists, like the famous physicist John Wheeler, suggested that conscious observers might not just see the universe, but help bring it into reality. If this is true, fine-tuning and consciousness might not be two separate things. Instead, the universe could be fine-tuned because conscious observers are required to complete the picture. In this view, consciousness and fine-tuning are locked together in a feedback loop. This process could also include life itself. People and other conscious beings are not only the result of fine-tuning, they are also a part of the system that sees and understands it. Life could be like the universe's senses, helping the universe understand itself through the minds, eyes, and ears of living things. This means that awareness is not just a result of fine-tuning, it is also part of what it is meant to do. It takes life for the universe to fine-tune its principles, and life in turn returns the universe back to itself. This idea ties together current science and old philosophy. In many cultures, people thought that humans lived to see how the world was made. Also, consciousness is very fragile, which makes fine-tuning even more important. A world needs a stable temperature, protection from harmful radiation, and access to the right chemicals in order to be able to support conscious people. For example, the Earth's magnetic field protects us from the sun's harmful rays. If this magnetic field wasn't as strong, complex life might not have been able to live long enough to become aware of itself. This means that fine-tuning isn't just about making life possible. It's also about keeping the conditions right over billions of years so that life can become smart and aware. There are two main ideas that experts have about how to explain fine-tuning. One idea is the multiverse theory, which says there are a lot of different worlds, each with its own set of physical laws. In this case, our world is just one of the few where the constants hold life and awareness together. The other idea, which is more debatable but more interesting, is that fine-tuning is done on purpose. This idea says that fine-tuning happens because universes that make aware viewers are somehow better than universes that don't. So awareness isn't a mistake. It's something that helps decide which worlds stay alive and which ones die. Several physicists say that if universes reproduce by doing things like making black holes, the ones that can develop complex structures and finally intelligence are the ones that are most likely to live. Fine-tuning would no longer be a secret, but rather a part of a process called cosmic selection, in which the universe is slowly learning how to make conditions that lead to its own awareness. Implications of a conscious universe on cosmic evolution. Immediate implications include the possibility that adaptive cosmic features may be displayed by a cosmos with intrinsic awareness. Conventional evolutionary theory holds that environmental stresses combined with genetic variety produce life on Earth. Analogously, if cosmic awareness exists, the informational and integrative qualities of the universe might gently direct the development of major structures such as galaxies, galaxy clusters, and the cosmic web. Consciousness could be a self-organizing factor that shapes the way matter and energy combine and spread themselves. For example, the complex equilibrium seen in the cosmic web, with its packed nodes and vast voids, may not be a simple accident of gravitational dynamics, but rather emerge from a deeper, consciousness-driven mechanism, striving for optimal complexity and interconnectedness. There may be feedback loops between awareness and physical development that work in ways similar to how homeostasis works in living things. Feedback loops keep living things stable by changing internal processes in reaction to changes in the outside world. If you apply this idea to the universe as a whole, you might think that an aware universe would also keep an eye on and change its own state. There may be a basic desire to maximize integrated information, which can affect how energy moves, phases change, and matter is distributed. This is known as cosmic coherence. In this possible future, things like the birth of stars, the crashes between galaxies, and even the speeding up of the expansion of the universe could be seen as parts of a larger process that keeps things in balance. A process like this might help structures form that add to the complexity of the universe. This could create a feedback loop where more complexity leads to more cosmic awareness, which in turn affects the growth of matter and energy in even more ways. If the world is aware, it might change how we think about thermodynamics and entropy. The second rule of thermodynamics says that systems tend to become more chaotic, which will eventually cause the world to heat die. But if consciousness is an important part of how the universe evolved, it could smooth out entropy by arranging matter in more complicated ways, even though the overall trend is towards chaos. This thought might not necessarily go against the rules of thermodynamics, but it could mean that localized decreases in entropy, like when stars and galaxies form, are not random, but rather part of a bigger, consciousness-driven process that makes things more complicated. Basically, consciousness might be something that resets or reorganizes parts of the universe every so often, which changes the long-term path of the universe. Adding awareness to the process of cosmic development may also have effects on the beginning of life. According to traditional ideas, life happens because the conditions are right. If awareness is built into the universe, then the start of life could be seen as a natural step in a conscious, self-organizing world. Life could be a state in the middle of the complexity scale, a link between inanimate matter and the higher order awareness that could someday fill the whole universe. The emergence of life, a reflection of universal awareness. The start of life on Earth is one of the most amazing events in the history of the universe. Some scientists now say it might be seen as a sign of the universe's hidden intelligence. According to traditional views of abiogenesis, life began naturally when the right chemicals reacted in the right way under the right circumstances. But if we consider the idea that the universe has a general kind of awareness, then the rise of life might not be seen as a random event, but as a normal part of a universe that is self-organizing and changing. In this framework, life is conceived as a necessary bridge between inert matter and a higher state of universal consciousness. The finely tuned physical constants of the universe have created conditions that not only permit the formation of stars, planets, and complex chemical compounds, but also facilitate the emergence of self-organizing systems. Once these systems reach a certain threshold of complexity, they begin to exhibit properties such as metabolism, replication, and adaptation that are strikingly reminiscent of the processes underlying conscious awareness. The intricate dance of molecules in primordial soups, the formation of protocells, and the eventual rise of organized, self-sustaining biological systems could be interpreted as the universe gradually waking up to its own potential for complexity. From a panpsychist point of view, even the simplest parts of matter may have some kind of experience, even if it is much simpler than human awareness. As these proto-experiences mix and engage in chemical and physical networks that get more complicated, they might lead to what we know as life. From this point of view, life is not a separate event. It is a sign of the universe's ongoing push for more unity and complexity. As a result, the appearance of life is an important developmental step, a kind of cosmic checkpoint, at which matter changes from just existing to a state where it can feel, process, and send information. This interpretation also casts the evolution of life in a new light. Rather than being driven solely by random mutations and natural selection, biological evolution might be seen as a process subtly guided by the inherent tendencies of the universe toward increased complexity and integration. The proliferation of life, from simple prokaryotes to complex multicellular organisms, can be viewed as an expression of the universe's own creative impulse, a slow unfolding of consciousness that gradually amplifies the capacity for subjective experience. As living systems become more intricate, they develop neural networks and sensory apparatus that allow for even richer forms of awareness, ultimately culminating in the complex human mind, which not only experiences the world, but also reflects upon its own existence. Self-organization in the cosmic web and its similarities to brain function. In both biological and cosmic systems, self-organization is a basic process that lets complex structures form on their own from simpler interactions without the need for a central manager from outside the system. Billions of neurons in the brain work together in small groups following simple rules. These groups communicate with each other through synaptic signals and feedback loops, which create the complex web of thoughts, feelings, and awareness. In the same way, the cosmic web, which is made up of galaxies, dark matter strands, and clusters, organizes itself on a large scale. This creates highly ordered and changing structures that shape how the universe evolves. In the brain, self-organization is vividly demonstrated through neuroplasticity. Neurons continuously form, strengthen, or prune connections based on both genetic programming and experiential input. This adaptive reconfiguration enables learning, memory, and recovery from injury. Neural networks exhibit emergent properties. Although each neuron follows relatively simple rules, their collective behavior results in phenomena that are far more complex than the sum of individual neuronal activities. Patterns such as rhythmic oscillations, synchronization among neuronal clusters, and the formation of functional modules enable the brain to process information efficiently and adapt to changing conditions. The creation of the cosmic web can be seen to follow similar steps. At first, right after the Big Bang, the world was mostly made up of particles and radiation. Over billions of years, gravity caused small changes in density that started with quantum changes in the early universe. These changes grew over time. These small changes were made stronger by nonlinear interactions, which caused matter to gather into strands, clumps, and empty spaces. Astronomical studies have drawn a lot of maps of this large-scale structure. It wasn't planned by someone outside the universe. It just happens naturally as particles interact with each other, controlled by gravitational forces and the expansion of the universe. In this way, the cosmic web is a self-organized structure where order forms from chaos at the start. The way their networks are set up is a notable similarity between the brain and the cosmic web. You can think of both systems as small world networks, where most nodes, neurons or galaxies, are only a few steps away from each other. This makes contact quick. In the brain, this network structure makes signal transmission more efficient, which allows coordinated reactions and a single awareness. In the cosmic web, areas that are closely packed together act as hubs, directing gravity forces and shaping the structures that form around them. These hubs remind me of the rich club effect in neural networks, where areas with a lot of connections are at the center of how information is processed. Another often seen characteristic are feedback loops. Feedback systems in brain systems provide for real-time changes necessary for learning and homeostasis maintenance. For example, the brain constantly adjusts synaptic strengths to maximize performance by means of sensory information. In the cosmic web, too, feedback mechanisms, such as those motivated by active galactic nuclei or supernovae, control matter dispersion and star formation. Energy liberated from these processes can heat interstellar gas, preventing more collapse or acting as a stimulus for fresh star formation, thus preserving a dynamic equilibrium within galaxies. Both the brain and the cosmic web exhibit modularity, a tendency to form distinct subnetworks that are internally well connected but loosely connected to other modules. In the brain, modular organization allows for specialization, where different modules perform specific tasks, such as language processing or visual recognition, yet integrate seamlessly to produce unified conscious experience. In the cosmic web, galaxies tend to form in groups or clusters that are distinct from one another, yet these clusters are interconnected by filaments. This modularity supports the resilience and adaptability of both systems, as the failure or change in one module does not necessarily compromise the integrity of the entire network. The similarities go all the way to how things change. Brain activity that is both random and well organized can lead to sudden changes, like phase transitions, where a small disturbance can cause neural networks to change in big ways. This event is shown by moments of discovery or artistic breakthroughs. When galaxies join, they can change the shape of places in space in big ways. And when big clouds of gas fall, they can cause starbursts. Both cases show how small interactions that get bigger over time can lead to big world trends. The role of dark matter in structuring the cosmic brain. Dark matter remains one of the most mysterious and fundamental components of our universe, constituting roughly 27% of its total mass energy content. Although it does not interact with electromagnetic radiation, rendering it invisible to telescopes, its gravitational influence is unmistakable. Dark matter forms vast halos that envelop galaxies and act as the scaffolding for the cosmic web. In the context of the cosmic brain hypothesis, these dark matter structures may serve as the underlying framework that shapes the universe's information processing capabilities. The gravitational pull of dark matter is critical in organizing the large-scale structure of the cosmos. Galaxies are not randomly distributed. Instead, they reside within dark matter halos that draw in and hold together luminous matter. These halos help dictate the motion of galaxies and the formation of intricate filamentary networks that interconnect galaxy clusters. Analogous to the supportive architecture of a biological brain, where glial cells provide structure and metabolic support for neurons, dark matter halos may provide the necessary stability and connectivity that enable cosmic information processing. Moreover, the way dark matter is distributed shows traits of a neural network. The dark matter network is arranged into dense nodes and elongated filaments, much as the human brain is arranged into densely linked areas that interact via sophisticated paths. As gravitational centers, these areas of strong dark matter concentration channelize matter and energy over the universe. Like central processing units in a neural network, integrating data from many sources, such hubs are fundamental for preserving the coherence and dynamism of the cosmic web. The role of dark matter in cosmic evolution extends beyond merely providing structural support. The interactions and merging of dark matter halos during galactic collisions, for example, can lead to the reconfiguration of cosmic structures, reminiscent of synaptic plasticity in the brain. This dynamism suggests that dark matter not only scaffolds the universe, but also participates actively in its ongoing reorganization and evolution. In this way, dark matter might be thought of as a kind of cosmic connective tissue, transmitting the gravitational signals that coordinate the movement and assembly of matter on a grand scale. Even more so, how neurotransmitters affect neuronal transmission. Some theorists have postulated that dark matter may modulate cosmic energy flows, though its exact form is still unknown, whether it is axions, weakly interacting mass particles, WIMPs, or something else entirely. Its ubiquitous existence guarantees that dark matter determines the gravitational terrain in which all cosmic events take place. This formation of the terrain influences the channels of information and energy distribution around the cosmos. The idea that dark matter contributes to the architecture of a cosmic brain is, of course, highly speculative. Critics point out that while dark matter's gravitational effects are well documented, there is no direct evidence that it processes information in a way analogous to neural activity. Nonetheless, the structural similarities are compelling. Both the brain and the cosmic web rely on an unseen, yet fundamentally organizing component, glial cells and dark matter respectively, that enable the formation of complex, integrated networks. If we consider the possibility that consciousness is related to the integration of information across a network, then dark matter's role in forming and sustaining the cosmic web becomes especially significant. It provides the large-scale framework that supports the emergence of complex structures, from galaxies to potentially even a diffuse, universal form of consciousness. Although many questions remain unanswered, particularly concerning how or if dark matter contributes to information processing, the parallels between its function and the supportive elements in biological systems offer a fascinating perspective on the cosmic brain hypothesis. The role of dark energy in the dynamics of cosmic consciousness. Dark energy, a mysterious force that permeates all of space and drives the accelerated expansion of the universe, constitutes roughly 68% of the total mass energy content of the cosmos. Although its precise nature remains one of modern physics' greatest enigmas, dark energy's influence on cosmic evolution is undeniable. In the context of the cosmic brain hypothesis, dark energy may play a critical role not only in shaping the large-scale structure of the universe, but also in the dynamics of universal consciousness. Fundamentally, dark energy may be understood as a kind of negative pressure balancing the gravitational attraction. The noted acceleration in the universe's expansion can be attributed to this repelling influence. Conventional wisdom holds that dark energy is a background field allowing cosmic evolution to take place. From the perspective of cosmic awareness, however, dark energy's expansive character may function as a dynamic force that refreshes the cosmic network, therefore allowing it to develop toward higher degrees of complexity. The way dark energy and dark matter interact is very important in a world that is thought of as a huge computer system that processes information. Dark matter holds the cosmic web together by connecting galaxies and clusters into a web of strands. Dark energy, on the other hand, causes the web to grow and maybe even change its shape. This two-part job makes me think of a balancing act. Dark matter's gravity pulls structures together, and dark energy's energy pushes them apart. This keeps the cycle of structures coming together and spreading out going. This kind of cyclic behavior might be like the pulsing rhythms found in living things, which need times of activity and rest, or growth and death, to keep their complex structures fresh. This dynamic interplay might have implications for the emergence and evolution of cosmic consciousness. If consciousness is related to the integration and processing of information within a network, then the constant, albeit gradual, reorganization of the cosmic web driven by dark energy could facilitate novel forms of information integration. As the universe expands, new regions of space open up and previously disconnected areas might come into contact, potentially allowing for new connections that contribute to the overall coherence of a cosmic mind. The thought of universal entropy may also have something to do with dark energy. The second rule of thermodynamics usually says that the world should move toward a state of maximum entropy. This will eventually cause a heat death, where energy gradients can't be used to do any useful work. However, if dark energy is actively expanding and reorganizing the structures of the universe, it may create a process that helps entropy drop in certain places. These areas with more order could be seen as new islands of complexity, similar to how ordered thinking starts to form in a biological brain. Cosmic cycles and the evolution of universal consciousness. Ancient cultures frequently observed cyclical patterns in nature, the seasons, the phases of the moon, and the cycles of day and night, and many interpreted these rhythms as evidence of a living, pulsating cosmos. For instance, Hindu cosmology envisions time as divided into vast cycles called kalpas, during which the universe is created, sustained, and eventually dissolved, only to be reborn. Similarly, ancient Greek thinkers like Heraclitus emphasized that change and flux are the only constants, encapsulated in his famous assertion that one cannot step into the same river twice. Such perspectives naturally lent themselves to viewing the cosmos as a living entity that evolves over time, with each cycle bringing about new possibilities for the emergence of complex phenomena, including consciousness. Modern cosmology has provided empirical support for cyclic models of the universe as well. Theories such as the ekpyrotic model and various oscillatory cosmologies propose that the universe undergoes periodic expansions and contractions. In these scenarios, the universe may experience phases of rapid growth followed by contraction, culminating in a big bounce that leads to a new cycle. This cyclical view challenges the traditional narrative of a singular Big Bang and an eventual heat death, instead suggesting that the universe may continuously renew itself. The implications of cosmic cycles for the evolution of universal consciousness are significant. If consciousness arises from the integration of information across complex networks, then each cycle of cosmic evolution might represent a fresh opportunity for this integration to occur at increasingly sophisticated levels. In the early phases of a cycle, when the universe is relatively homogeneous and low in complexity, consciousness may be minimal or even absent. However, as the cycle progresses and structures such as galaxies, stars, and ultimately life emerge, the level of integrated information may increase. This could lead to the gradual emergence of localized pockets of consciousness, first in the form of simple, proto-conscious states in matter, and eventually in the complex, self-aware forms seen in living organisms. The way that natural cycles change things over time may work as a way to restart things. The brain benefits from sleep because it helps neural networks organize and strengthen memories. In the same way, a circular universe might go through phases that help its structure and informational networks change their layout. During these stages, the cosmic mind might have times when it is more fully integrated, which could lead to short-lived states of heightened awareness or even global spread consciousness. In human societies, times of crisis or renewal cause thought and behavior to change quickly. These events might be similar to those times of insight or group cognitive shifts. Even if cyclic cosmology's mathematics is convincing, critics say it's quite speculative to relate these cycles to the birth of awareness. We still don't fully understand the link between the physical processes that control cosmic cycles and the quality of mental experience. But supporters say that if the level of complexity and information integration in a system is linked to the rise of consciousness, then the repeated stages of cosmic evolution provide a natural way for a global consciousness to grow over time. Primordial quantum fluctuations and the birth of cosmic awareness. At the tiniest scales, quantum fluctuations are a natural and inevitable feature of the quantum field. In a universe where even the vacuum is teeming with temporary fluctuations, these tiny perturbations can be thought of as the noise that eventually becomes amplified by the rapid expansion of space. As the universe inflated, these fluctuations were stretched to macroscopic scales, imprinting slight variations in the density of matter that would later influence the formation of cosmic structures. The remarkable precision with which these fluctuations have been measured in the cosmic microwave background radiation attests to their fundamental importance in the universe's evolution. Panpsychism and integrated information theory, IIT, are two theories that try to explain where consciousness comes from. These primordial changes could also be seen as the first spark of universal awareness. Assuming that consciousness is a basic part of reality and can be found in even the simplest kinds of matter, then the quantum changes in the early universe might have been the start of proto-consciousness. Every change in this structure brings with it a small, basic part of experience that, when added together and sped up over cosmic timescales, helps more complicated kinds of awareness come into being. This notion offers a radical reinterpretation of the role of quantum mechanics in the cosmos. Rather than being confined solely to the microscale phenomena of particles and fields, quantum processes could also serve as the foundation for a continuum of consciousness that extends from the smallest fluctuations to the vast cosmic structures observed today. The idea is that as the universe cooled and structures formed, these proto-conscious elements embedded in the fabric of space-time began to integrate. Through the process of cosmic self-organization, the initially isolated quantum experiences may have merged into larger, more coherent entities, ultimately giving rise to the complex networks of matter and energy that underlie the observable universe. But going from quantum changes to a kind of cosmic awareness is a big guess that doesn't make a lot of sense. Quantum ripples are random and don't last long. One important question is how they can lead to something solid and long-lasting, like awareness. Some individuals think that a clear, unified awareness might be possible when many quantum events work together, like how many individual notes work together to make a complex melody. During inflation, these changes became much bigger. It may have also set the stage for things that were already there to come together. Integrating the concept of consciousness into our understanding of quantum fluctuations invites a re-examination of the measurement problem and the observer effect in quantum mechanics. Some interpretations of quantum theory propose that the act of observation collapses the wave function, suggesting an intimate connection between consciousness and physical reality. If even the earliest fluctuations were suffused with a minuscule form of awareness, then the boundary between the physical and the conscious becomes increasingly blurred. The nature of time and space in a conscious universe. A thought-provoking idea is that time might not be a set factor, but rather an emergent feature that shows how much a system changes and fits together. In living things, Our subjective experience of time changes all the time. When we're focused, time can seem to go on forever, but when we're bored, it's over in a flash. This ability to change shape suggests that time may be closely connected to how we think and process information. In an aware universe, time could be seen as a measure of how the universe is constantly changing and rearranging itself, with time itself showing how complex things are getting more complicated. Some scientists and philosophers have even thought that the arrow of time, which flows from the past to the future, might have something to do with the rise in entropy and the gradual integration of knowledge. Similarly, space may also be an emergent phenomenon rather than a pre-existing arena. Recent developments in quantum gravity and string theory suggest that space might arise from the entanglement patterns of underlying quantum states. If space is the result of complex interactions at the quantum level, then its structure could be fundamentally linked to the way information is organized and processed across the cosmos. In this light, the fabric of space-time may itself possess qualities akin to a neural network, interconnected, dynamic, and capable of supporting complex informational processes that could underlie a form of cosmic consciousness. If consciousness is not solely an emergent property of brain-like structures, but is a fundamental aspect of reality, then the nature of time and space might also be subject to conscious influence. Some interpretations of quantum mechanics, such as the participatory anthropic principle, suggest that the observer plays a critical role in shaping reality. In a universe where consciousness is woven into the fabric of space-time, the act of observation might not just collapse quantum wave functions, it could also contribute to the very definition and flow of time and the spatial relationships between cosmic structures. Neural correlates in the universe, comparing brain and cosmic networks. In the human brain, neurons are connected through synapses to form a complex network that exhibits both local specialization and global integration. The brain's architecture is characterized by modularity, where clusters of neurons handle specific functions, such as visual processing or language, and by small world properties that allow for rapid communication between distant regions. This structure enables the brain to process and integrate information efficiently, giving rise to unified conscious experiences. High-degree hubs, which are regions with an exceptionally large number of connections, play a critical role in ensuring that local neural activity is effectively synchronized with global brain dynamics. The cosmic web is made up of galaxies, galaxy groups, and huge filaments of dark matter that join them. Even though the forces that control these systems are different, electrochemical interactions in neurons versus gravity forces in cosmic structures, the networks that are formed are very similar. Galaxies are not spread out randomly. Instead, they tend to group together into clusters that are linked by long strands. This makes a structure that looks a lot like the small world shape that you can find in neural networks. In this cosmic network, crowded areas or nodes act as hubs where matter and energy gather, similar to how the brain's high-degree hubs make it easier to connect and share information quickly. The analogy extends to the concept of feedback loops. In the brain, feedback mechanisms are essential for regulating neural activity, facilitating processes such as learning and memory consolidation. Positive and negative feedback ensure that the brain remains both stable and adaptable, enabling a dynamic response to external stimuli. On the cosmic scale, feedback processes are observed in the interactions between galaxies and their environments. For instance, when active galactic nuclei expel energy in the form of jets, they can heat the surrounding interstellar medium, suppressing or triggering further star formation. This feedback, while operating on much grander scales, is crucial for the evolution and stability of cosmic structures, mirroring the regulatory functions found in neural systems. The idea of emergent complexity is another area where different ideas come together. In neural networks, simple neurons talk to each other using basic chemical and electrical signals to create the complex web of human cognition. This is a standard case of emergence. In the same way, the cosmic web is made up of the gravity forces of matter that was there before the Big Bang. Cosmic inflation made tiny changes in the early universe bigger, which is what caused galaxies and other larger structures to form. Over the course of billions of years, these self-organizing processes have made the world very complicated and well-organized. The new features seen in both systems show that general rules, like optimal connectivity and fast information flow, may control how complex networks form and change, no matter what size they are. Researchers can now simulate both brain and cosmic systems thanks to progress in computer modeling and network theory. These models show that many complicated networks have the same mathematical features, like power law distributions of connectedness and modular organization. The fact that these properties show up in such a wide range of systems makes it interesting to think that the processes that support consciousness in humans might have their counterparts in the cosmic world. It means that the basic rules that make brains work may also be at work in the way the world is put together. Even though these comparisons are interesting, it's also important to note the differences. The brain's neural networks work on instant rates through electrochemical processes. The cosmic web, on the other hand, changes over billions of years due to gravity and dark matter. The energy and physical scales are very different, and biological systems are still the only ones that have a direct link between neural activity and conscious experience. Still, the structural and functional similarities are an interesting mental bridge that makes us want to find out if the basic rules of network organization might be the same everywhere. The possibility of a universal mind through cosmic integration. The notion of cosmic integration builds on the understanding that the universe exhibits striking similarities to the neural networks found in the human brain. In the brain, billions of neurons interact in intricate ways to produce the emergent phenomenon of consciousness. Likewise, the large-scale structure of the universe, the cosmic web, displays a network architecture characterized by densely connected hubs, galaxy clusters, and extended filaments of matter and dark matter that interlink these nodes. These features suggest that similar principles of connectivity, self-organization, and feedback may operate at both scales. If the universe's fundamental constituents, ranging from elementary particles to entire galaxies, participate in a continuous exchange of energy and information, then it is conceivable that these processes could culminate in a form of universal awareness. Many people believe that the universe could have a mind, but that doesn't mean it would be conscious in the same way that humans are, with self-reflective thinking and emotional experience. Instead, it argues that the universe's connected and changing network could develop a type of distributed consciousness, a widespread, low-level awareness that is not the same as human consciousness, but still shows that there is some kind of cognitive quality at play. According to this point of view, individual minds, like the ones in our brains, may be small versions of this bigger, more cosmic mind. As the world expands and becomes more complicated and linked, new qualities may appear that are similar to parts of our own experiences. This concept also challenges the long-held dualistic view that separates mind and matter. Traditionally, Western thought has treated consciousness as something that arises only in certain complex systems, particularly biological organisms. However, recent theories, such as integrated information theory, IIT, and certain interpretations of quantum mechanics, suggest that consciousness might be an intrinsic property of all matter. If every region of space contains some degree of integrated information, then the cumulative effect of cosmic interactions could, in principle, lead to a universal form of consciousness. This idea dovetails with philosophical positions like Panpsychism and dual-aspect monism, which argue that mind and matter are two complementary facets of the same underlying reality. The assumption that a unified, coherent mind may arise from complicated physical interactions is, however, a matter of considerable speculation, according to critics. They bring up problems like the combination problem, which asks how simple, localized proto-conscious states can come together to make a single global awareness. Also, the huge difference in scales, from the fast, limited interactions in a neural network to the slow, gravitationally driven dynamics of the cosmic web, makes us wonder how integration might happen. Still, the appeal of a universal mind lies in its ability to provide a complete account that ties together mental, biological, and physical events in a single, logical way. If the universe really does have a general mind, it would mean a lot of important things. In this case, it could mean that awareness is not just a random result of evolution, but a fundamental part of the world that makes complexity and order possible. This point of view would change how we think about life and existence by seeing awareness as a localized form of a much bigger, more general thinking process. Experimental approaches to detecting universal consciousness. Advancements in astrophysical observatory are providing ever more detailed maps of the cosmic web. Telescopes like the Sloan Digital Sky Survey, SDSS, and space-based instruments such as the Hubble Space Telescope and the upcoming James Webb Space Telescope offer high-resolution data on the distribution of galaxies and dark matter. By applying sophisticated network analysis techniques to these datasets, researchers can quantify structural properties such as modularity, hub connectivity, and small world characteristics that are reminiscent of neural organization. If regions of the cosmic web display unusually high levels of integrated information, this could serve as an indirect indicator that the universe is organized in a manner conducive to emergent consciousness. Quantum experiments also contribute to this exploratory effort. The phenomenon of quantum entanglement, where particles become linked in ways that defy classical expectations, suggests that non-local connections might be a fundamental aspect of reality. Experiments testing Bell's inequalities continue to push the boundaries of our understanding of entanglement. Some researchers have proposed that if entanglement persists on increasingly macroscopic scales, it might reveal underlying principles of connectivity that are relevant to a universal mind. Although the current state of technology limits such experiments primarily to the microscopic realm, future advancements in quantum sensing and measurement may allow scientists to probe entanglement effects on larger scales, potentially bridging the gap between quantum phenomena and cosmic structure. Interdisciplinary experiments are also emerging at the interface of cognitive science and cosmology. For instance, analog models that simulate complex networks using physical systems like fluid dynamics or electronic circuits can help researchers understand how simple local interactions might give rise to emergent global properties. These laboratory analogues provide a controlled environment in which the principles of self-organization and information integration can be tested and observed. Insights gained from such experiments may eventually inform theoretical models that link the behavior of neural networks with the large-scale organization of the universe. Alternative theories explaining cosmic connectivity without consciousness. Many people are interested in and argue about the idea of a conscious universe. However, there are other ideas that say the amazing connections seen in cosmic structures can be explained by physical processes alone, without relying on universal awareness. These ideas say that the universe's big structure, how information moves, and new qualities can be seen as natural results of self-organizing rules, gravity dynamics, and how complex systems behave. The idea of emerging complexity is a well-known option. This idea says that the cosmic web, galaxy clusters, and dark matter strands, which are all linked structures in the universe, are made by bottom-up processes that come from the basic laws of physics. Self-organization in these systems is driven by nonlinear dynamics and random interactions. This lets simple local interactions lead to patterns on a large scale. There doesn't have to be a conscious plan for order to show up, like in the filamentary network of galaxies. Instead, it can be seen as a natural result of gravitational pull and the interaction between dark matter and dark energy. This point of view is similar to well-known things that happen in complex systems. The whole shows traits that aren't clear from its parts, and it does this without any active conscious planning. Statistical mechanics and thermodynamics give us another way to look at things. the world is seen as a very large group of particles and fields that naturally change into more ordered and less chaotic arrangements, as the second law of thermodynamics says they must. The second law says that things are getting more and more chaotic, but small decreases in entropy happen naturally in a bigger chaotic system. For example, stars, galaxies, and even living systems form when entropy goes down. In this model, the way that cosmic structures are connected and make sense are explained by chance effects. They are not signs of a universal mind. Instead, they are the result of minimizing energy and making the best use of gravity potentials. This explanation is based on well-known physical rules and doesn't need the idea of intrinsic awareness. Cosmic connectedness can be explained non-consciously by theories based on information theory. Some experts say that the world can be thought of as a huge computer system that processes information. The only way that information is added and moved is through physical interactions. The patterns seen in the cosmic web are caused by the way space-time and matter work naturally. These include entropy gradients and energy distributions, which make it easy for information to be sent and processed. In contrast to views that link these events to a conscious viewer, the information theoretic view sees them as emerging features of the universe's basic physical structure. Quantum physics also gives us different points of view. For example, quantum interaction shows that particles can have connections that don't make sense from a traditional point of view. Some people say that entanglement is a sign of a universal mind, while others say it is just the way that the basic rules of quantum physics show themselves. In this case, the fact that entangled systems show non-locality does not mean that the world is aware. Instead, it means that reality is deeply linked through clear quantum rules that work even when we are not aware of them. Criticisms and skepticism of the cosmic brain. Hypothesis. Combination trouble is one of the main complaints. Some types of panpsychism say that even elementary particles have a basic form of consciousness. If this is true, then one of the biggest problems is figuring out how these small-scale experiences come together to make the big-scale consciousness we see in complex animals. Skeptics say it's hard to understand how we could go from simple, isolated proto-conscious states to a unified global cosmic mind. However, the ways that different aware parts might come together to form a single global mind are still mostly hypothetical and not backed up by evidence. The cosmic brain hypothesis's unfalsifiability is the subject of another important criticism. There are people who disagree with this, including scientists, who say that a theory is not empirical if it can't be thoroughly tried or proved wrong. A lot of people who believe in the cosmic brain use things from quantum physics, like the observer effect and entanglement, to back up their claims. But those who disagree say that these quantum effects are well known within the established frameworks of physics, and that using them to support the idea of a global awareness is often going too far, as shown by current scientific evidence. If there aren't any clear forecasts or tests in the lab, the hypothesis might just stay a complicated philosophy figure of speech and not a strong scientific theory. Neural processes happen in milliseconds and involve very specific electrical reactions in the brain, which is a well-defined closed system. The cosmic web, on the other hand, changes over billions of years and is controlled by gravitational forces working on big, spread-out structures made mostly of dark matter and dark energy. Some people say it's not possible to directly compare how a biological brain works to how the world works because of the differences in scale, both in terms of time and physical processes. Even though the comparison is powerful, it may oversimplify or misunderstand how the two things are really working. Philosophically, there is also disagreement about whether the idea of a global brain makes sense. Many people criticize traditional dualist or even neutral monist theories that try to explain the relationship between mind and matter because they don't explain the qualitative aspects of consciousness, the so-called hard problem, or because they use consciousness as a metaphor for things that may not have any phenomenological qualities. Some thinkers, like Daniel Dennett, have called these kinds of theories just another form of mysticism because they don't help us understand consciousness in a way that is consistent with science. Skeptics also bring up the question of cause-effectiveness. It is thought that conscious experience starts in the brain when neurons connect in ways that are controlled by well-known physical rules. For the cosmic brain hypothesis to be true, the ways that knowledge at the cosmic level could be put together to make a type of consciousness must be shown to work. Cause and effect process. Future technological innovations in cosmic consciousness research. As our scientific tools and computer programs keep getting better, a new area is opening up that might test and shed light on the idea of cosmic awareness. Next-generation cameras, quantum computing, and artificial intelligence, AI, are all new technologies that are coming together in interesting ways. These new technologies could help us learn more about the universe's structure and how it processes information. One of the most anticipated advancements in observational astronomy is the deployment of new, ultra-sensitive telescopes. Space-based observatories like the James Webb Space Telescope, JWST, and planned missions, along with ground-based giants such as the Extremely Large Telescope, ELT, are set to provide unprecedented high-resolution data on the cosmic web. These instruments will enable scientists to map the distribution of galaxies, dark matter, and energy with far greater precision than ever before. By analyzing this data with sophisticated network theory, researchers hope to uncover patterns of connectivity and integration that might hint at underlying processes analogous to neural information processing. The rise of AI and machine learning is revolutionizing the way we analyze large datasets. AI algorithms can sift through vast amounts of astronomical data to detect subtle correlations and patterns that may elude human analysts. For instance, machine learning models are being trained to identify and characterize the filamentary structures of the cosmic web, detecting the hubs and nodes where information might be most densely integrated. Such approaches could, in principle, provide empirical metrics for evaluating the degree of integrated information within cosmic structures, a key parameter in theories that connect physical processes with consciousness. Improvements in quantum technologies are making it possible to do new kinds of experiments. Quantum monitors and communication tools are getting more delicate, which means that small quantum effects can be seen on bigger scales. Soon, experiments that look into quantum coupling and non-locality might be able to tell us if quantum connections can be found in the big picture of cosmic structures. If these kinds of correlations are found to hold true on bigger scales, they could be indirect proof that the world is connected in a basic way that is full of information. Another tool that could have an effect on this area is quantum computing, which can simulate very complicated quantum systems. Quantum computers could help us understand how the tiny changes in the beginning of the universe turned into the big structures we see today by modeling the quantum dynamics of particles interacting on a scale that matches the early universe. These models could help us figure out if the rules that govern how quantum information is processed could possibly be used to make proto-consciousness in the universe. Interdisciplinary initiatives are increasingly bridging the gap between theoretical models and observational data. Projects that combine expertise from astrophysics, neuroscience, and computer science are being developed to model the universe as an information network. Implications for human consciousness and its connection to the cosmos. If the universe is a single connected information processing machine, or even if it has a sort of consciousness that is spread out, it could have huge effects on our own consciousness. This view goes against the common belief that our minds are separate products of biological evolution. Instead, it suggests that awareness is closely connected to a bigger network of information in the universe. As a first effect, this means that each person's consciousness is being changed. We might start to see our subjective experiences as limited expressions of a universal awareness, instead of seeing them as things that happen because of complicated neural processes. From this point of view, the brain is like a powerful receiver that picks up and processes signals from the global network while also sending its own signals. Because everything is linked, the things we think of as conscious, like awareness, perception, and even creation, may just be reflections of deeper, more universal truths. This perspective has potential ramifications for fields ranging from neuroscience to psychology. For instance, if consciousness is not an isolated, emergent property, but rather a fundamental aspect of the universe, then studying the brain might reveal parallels with cosmic processes. Neuroplasticity, the brain's ability to rewire itself in response to experiences, might then be seen as a microcosm of the universe's capacity for self-organization and renewal. Moreover, if our cognitive processes are influenced by universal patterns of information integration, this could explain why certain themes, symbols, and narratives recur across diverse cultures and epochs. Mythological motifs and spiritual experiences that describe unity and oneness might reflect our intrinsic connection to a larger cosmic fabric. The idea of cosmic connectedness also holds implications for human identity and ethics. Recognizing that our consciousness is intertwined with the universe might foster a sense of responsibility toward the environment and other living beings. This holistic view challenges the dominant individualistic paradigms of modern society by emphasizing interdependence. When we see ourselves as integral parts of a vast, interconnected whole, the ethical imperative to care for our planet and its inhabitants becomes more compelling, a perspective that aligns with many Eastern spiritual traditions and emerging ecological philosophies. In practical terms, this cosmic perspective could influence how we approach mental health and well-being. If human consciousness is part of a broader cosmic process, then therapies that incorporate holistic practices, such as mindfulness, meditation, and other forms of contemplative practice, might be understood not merely as stress relief techniques, but as methods of attuning ourselves to the underlying rhythms of the cosmos. Such approaches may help individuals achieve a sense of unity and balance, reducing feelings of isolation and fragmentation that are common in contemporary society. Philosophical perspectives on the unity of mind and matter. Plato, one of the earliest proponents of a unified cosmos, introduced the notion of the anima mundi, or world soul, in his dialogues such as Timaeus. For Plato, the cosmos was not a random assembly of inert matter. Rather, it was a living entity in which every part participated in a larger, rational order. His theory posits that individual souls partake in the eternal forms, abstract, perfect ideals that embody the true essence of things, thereby bridging the gap between the material world and the realm of pure intellect. This early vision laid the groundwork for later thinkers who sought to understand how consciousness might be intrinsic to the fabric of the universe. Aristotle further developed these ideas by arguing that the soul, psyche, is the form of the body, its essential organizing principle. In his framework, every living organism possesses a soul that imbues it with life and purpose. Yet this soul is not something separate from the body. Instead, it is its defining feature. Aristotle's view dissolves the stark dualism between mind and matter by emphasizing their interdependence. The soul gives shape to matter, and matter provides the substrate in which the soul operates, creating a unity that underpins all living things. In the early modern period, René Descartes introduced Cartesian dualism, famously asserting cogito ergo sum, I think therefore I am. Descartes drew a clear distinction between the mind, res cogitans, and the body, res extensa, treating them as fundamentally different substances. However, his approach also led to persistent puzzles, such as the interaction problem, about how these distinct entities could causally interact. This critique paved the way for alternative perspectives that aim to overcome dualism's limitations. Baruch Spinoza offered a radical departure from Cartesian dualism with his monistic philosophy. Spinoza argued that there is only one substance, which he identified as God or nature, Deus sive natura. and that mind and matter are simply two attributes of this single, unified reality. This view of dual-aspect monism suggests that the mental and the physical are inseparable facets of the same underlying substance, a concept that resonates with modern discussions of the unity of mind and matter. Gottfried Wilhelm Leibniz, with his theory of monads, contributed another unique perspective. He posited that the universe is composed of an infinite number of simple substances, monads, which are not extended in space, but possess internal mental qualities. Although each monad is a distinct individual entity, they are harmoniously synchronized through what Leibniz called pre-established harmony. This elegant solution to the mind-matter problem underscores the idea that mental properties might be inherent in the fundamental building blocks of reality, even if these properties are vastly simpler than human consciousness. In the 19th and 20th centuries, philosophers like Arthur Schopenhauer and Hegel revisited the relationship between mind and matter from fresh perspectives. Schopenhauer, for instance, argued that the world is will and representation, where the underlying will is the driving force behind all phenomena. His view implies that the apparent separation between the physical world and inner experience is illusory, as both stem from the same fundamental force. Hegel, on the other hand, used a dialectical method to describe the evolution of the absolute spirit, suggesting that individual consciousness is but a fragment of a larger, unfolding cosmic mind, a process that unifies all oppositions through synthesis. Philosophers today are looking into this issue with even more passion. David Chalmers, for instance, has looked into Panpsychism and dual aspect theories, saying that consciousness may be a basic feature of the world. Galen Strawson and Philip Goff both say that the basic makeup of matter might contain early forms of consciousness. This goes against the common belief that consciousness only develops in complex brain networks. The universal brain and the future of cosmic self-awareness. The universal brain theory says that the universe is set up like a very large neural network. In the same way that neurons in the brain talk to each other through complex synaptic links, gravity and electromagnetic forces join galaxies, dark matter, and cosmic filaments. The large-scale structures of the cosmic web are made up of interactions between these particles. These structures have traits like feedback loops, high connectedness, and modularity that are very similar to the way neural networks are organized. If the structure of the universe can be modeled using the same mathematical models that describe how brains are linked, then it is possible that the universe could handle information like a brain. This possibility brings up very important questions about what awareness is. Consciousness happens in the brain when information from billions of neurons that are all linked to each other is put together. Could something like this happen in the universe? Some people think that as the world changes, its growing complexity and interconnectedness could lead to a new, spread-out kind of knowledge. It's possible that this universal mind wouldn't have the deep, self-reflective traits of human consciousness. Instead, it could show up as a diffuse, collective form of cognition, a kind of cosmic self-awareness that brings together all the knowledge in the world. The effects of a universal brain go far beyond what scientists can imagine. Future study that finds evidence for the idea that the universe is an aware, integrated system would completely change how we think about life, meaning, and our place in the universe. People have usually thought of human consciousness as an unusual and new biological event. However, this idea could be changed to see consciousness as a localized expression of a much bigger, more universal process. Not only could this change the way scientists think about neuroscience and physics, but it could also have real-world effects on ethics, faith, and even technology. Recognizing a universal mind, for example, could help all living things feel more linked to each other, which could lead to moral systems that stress global responsibility and environmental survival. If everything in the universe is connected and part of a shared, changing awareness, then damaging or using up any part, whether it's a forest, an ocean, or a species, could be seen as a threat to the universe's overall health. This view could change the way we handle the environment, and how people in general feel about protecting nature and using natural resources in a smart way. The universal brain hypothesis may inspire technological innovations designed to interface with the cosmic network of information. Advances in artificial intelligence, quantum computing, and complex systems modeling might one day allow us to tap into or simulate aspects of cosmic self-awareness, opening new frontiers in data processing and communication. The dream of a symbiotic relationship between human intelligence and a conscious cosmos could lead to revolutionary developments in how we harness and integrate information, potentially transforming everything from scientific research to everyday life. Our exploration has taken us on a transformative journey through the evolution of cosmic consciousness, from ancient myths and classical philosophy to cutting-edge scientific theories that challenge the boundaries between mind and matter. As we continue to push the frontiers of understanding, these interdisciplinary insights not only enrich our grasp of the universe's intricacies, but also invite us to reconsider our own place within this grand cosmic tapestry. We invite you to join us as we delve deeper into these compelling ideas. Subscribe for more thought-provoking content, share your insights, and engage with a community of curious minds dedicated to unraveling the mysteries of consciousness and the cosmos.